Hey there, factoring folk. We're going to continue our unit on polynomial equations, and so we have to continue factoring expressions. And so far we've been really good at factoring quadratic trinomials and even special versions of quadratic trinomials, and even using substitution to get to quadratic trinomials. But then we have to jump right into this next logical step, which is what happens when we have cubes, perfect cubes. This is a popular factoring method, and it's going to pay off dividends later in future units. But since we're dealing with factoring now, we should talk about how is it that we can factor sums and differences of cubes, because what has been discovered is that every time you have two perfect cubes being added, also known as a sum of cubes, whenever that has happened, it's been the result of multiplying the same thing every time. So we now have a formula-ish or a format for factoring a sum of cubes, because it just seems to always work out this way. So that whenever you have a sum of cubes, it can be factored into the same exact product every time. So if you have one perfect cube here, a to the third power, and another perfect cube here, b to the third power, what always happens is that it is the product of the a times the b, or a plus the b, sorry. It's the product of the a plus the b, whatever this is, plus this, multiplied by the a squared. Then it's going to be minus the a times the b, and then plus the b squared. And the signs are always going to be the same. So this just happens to occur every time. So if we were to find something like this, and we were to multiply the whole thing out using the area model or the distributive property, we would end up with the sum of the cubes. So when we look at factoring each expression here, and I start number one on purpose to have that basic, I'm basically introducing the formula for a sum of cubes with number one. That just happens to be how it works. So notice what's happening with the signs and the factoring. So there's something interesting. When we have a sum of cubes, take a look at the signs. The first sign is the same. The second sign is the opposite. And then the third sign is positive. And that's going to remain throughout sums of cubes and difference of cubes. Just want to notice that the first sign is the same. The second sign is the opposite of the sum. And then the third sign is positive. And that's going to lead us into a neat little shortcut later. But that's what a sum of cubes is, because every time you see something like this and you're to multiply it out, you end up with a sum of cubes. It always happens that way. So then what we can now do is take that fact, use this form to factor sums of cubes. So here's an example. Look at that second expression, 8x cubed plus y cubed. You know what's interesting about that expression is that is a sum of cubes. So taking into consideration what we had talked about throughout this unit, which is basically recognition. Basically recognition. If you can recognize that this is actually a sum of cubes, right? This is actually a cubed plus b cubed. It just so happens that a is 2x and that b is y. It's all about recognition. Did you know that a happens to be 2x? Because if we were to take 2x to the third power, if we were to take 2x to the third power, you know what we would have? 8x cubed. This is how it works. 2 to the third power is 8. X cubed is x cubed. So it just so happens that is a to the third power if a is 2x. B is just simply y. And so we're using that substitution method as well, being recognizing what's happening. So if we were then to recognize this, what we could do is use substitution for that format that we have that we had talked about in the previous problem. We can use substitution for that format. So what we can do then is rewrite that format because it'll help you remember some things. So if you remember how we factor a cubed plus b cubed is same sign, then a squared opposite sign, and then positive. Okay, so that's just remembering that format. And then what we can do is substitute back. So we have taken this, used that factored format, and then we can substitute back. So if you remember what we had substituted originally, we said that a is actually 2x, right? So a to the third power, in this case, would be 2x to the third power. So a is actually 2x, so we can substitute back. B is actually y, so we can substitute that back. And then see what's happening there. And then we'd have a squared, but remember a was 2x, so we're actually looking at 2x squared. And then minus a times b, or minus 2x times y, or 2xy, and then plus b squared. So we use the format and then substitute back. All right, and that's how factoring would work with a sum of cubes. Okay, so we once we see the format, we noticed our substitution, we can then substitute right back and then just simplify what we can. So our first term, our first factor, if you will, 2x plus y is our first factor. And then 2x to the second power is actually 4x squared. And then minus 2xy plus y squared. Okay, so that is how we would factor that first expression, or that second expression, because we're using that format that just always seems to work out. And again, if we were to distribute this all the way through, we would end up with our sum of cubes. And here's the check. I'll prove it to you. So 2x times 4x squared, 8x cubed. 2x minus 2xy minus 4x squared y. 2x times y squared plus 2xy squared, right? And then y times 4x squared plus 4x squared y. And then y times minus 2xy minus 2xy squared. And then y times y to the squared is y to the third power. And so we've multiplied everything back. Now we can combine our like terms. Then we see minus 4x squared y plus 4x squared y totally cancels. And then plus 2xy squared minus 2xy squared cancels. What are we left with? Our original sum of cubes. And so that's why I said that format for number one totally works. So it works out every time for the sum of cubes. So again, what we had talked about for number one, it always seems to factor into that product because if we were to multiply back out, we would end up with our substitution. So when we factor this expression completely for number two, when we factor that expression completely, we are left with this as the result. And that is how that is factored. And we actually cannot factor this term. So we cannot factor that, therefore we are done. All right, so that's how a sum of cubes works. Now let's move on to number three. So if you take a look at number three on here, it's a little bit trickier, but do you recognize we're still dealing with a sum of cubes? Okay, so it's about that recognition piece that I had talked about in previous lessons. So we actually are dealing with a sum of cubes if you can recognize. If you can recognize. What if we said A is 2x plus 3, and what if we said B is 4? Right? We are dealing now with perfect cubes. Okay, so we're dealing now with perfect cubes, and then we can use the format A cubed plus B cubed. And so we're dealing now with a cubed plus b cubed, considering a is 2x plus 3, the third power, b is 4, 4 to the third power is 64, and so we are set to go. So now what we can do is use that format, and remember how the format works for a sum of cubes. First thing is the sign is the same, then we have a squared, opposite sign, ab, and then positive plus b squared. And so what we do is recognize that format, and then switch back. Okay, switch back to what we had substituted. All right, so we're going to switch back to what we had substituted. What did we say a was? 2x plus 3, right? So we have 2x plus 3. And then we have plus b. What did we say b was? B was 4. All right, so we're going to switch that 4 back. And then that's our first term. And then we have a squared. So whatever our a was, we're going to square it. All right, and our a was 2x plus 3. So we're looking at 2x plus 3 squared. Hopefully you remember specials. And then we have minus a times b, okay, or minus 4 times 2x plus 3, which is 8x plus 12. Quick mental distributive property. Hopefully you caught that. Distributive property. Caught that. And then plus b squared, all right, or plus 4 squared. And the rest is simplification. So we have this, we switched back what we had substituted. The rest is just simplifying. All right, so we're going to simplify what we have. In our first factor, we have 2x plus 7 because we can combine our like terms. In our second factor, we have some things going on. If you remember, this is a special. We can multiply this whole thing out. All right, so that's 2x plus 3 squared is 4x squared plus 2 times a times b, or 12x, because it's 6x, double that, plus 12x, and then 3 squared is 9. And so we have our special, right? Now here we have to be careful with signs because we are subtracting this mess, right? So we have to be careful with signs. So we are subtracting this mess, minus 8x, and then minus 12, and then plus 4 squared is 16. Okay, so that's what's happening as we are simplifying that second term. And there's a lot of stuff that's going on, so we have to be super careful. And so we have 2x plus 7 is still our first factor, but then our second factor gets to be simplified. We combine our like terms. There's only one x squared, so that's fine. Now we have our x's. 12 plus 12x minus 8x is plus 4x. And then we have all of our constants. 9 minus 12 is negative 3, plus 16 is plus 13. And so we have now factored our expression. And again, if we were to multiply this out, we would end up with a sum of cubes, right? So if we would multiply this out, we would end up with a sum of cubes. So we have now factored that completely using the sum of cubes format. Okay, so that's it for sum of cubes. Now we get into number 4, and we see a difference of cubes. And here's where I can teach you the shortcut to remember how the formula works. So now if you're looking at number 4, now we have a difference of cubes. So hopefully you see that since we are subtracting perfect cubes, we now have a difference of cubes. Okay, a difference of cubes. So we had our sum of cubes here. Now what we're looking at is a difference of cubes. And so again, it happens from repeated multiplication. We find out there is a format, or a formula for a difference of cubes. So if we had a cubed minus b cubed, you know what that would factor into? Sign staying the same, Then we have a squared, then the opposite sign, very similar to what we've done before, and then the last one, positive. So it's the same format, but now we have a shortcut to remember sums and differences of cubes. So again, we notice that the sign stays the same for the first factor, and then when we're inside the second factor, then we have the opposite sign, and then this one is also positive. So for a sum and difference of cubes, we have a little acronym that hopefully you can remember with signs called SOAP. So SOAP stands for same, opposite, and then always positive, the last term. Oh, by the way, always positive. Same, opposite, always positive. So we have SOAP as our little acronym. So notice what happened to the sign. Same sign, the opposite sign, always positive, that last term. So it's something neat to hopefully help you remember how we use signs for sums and differences of cubes. But anyway, when we have a difference of cubes, it just always works out this way, so we can now use it as a form. So with number 4, since we are looking at basically the formula for a difference of cubes, it's factored using that formula. So the first factor has the same sign. Then in the second factor, we're going to have the opposite sign, and then a, b, and then always positive for the b squared. Just always seems to work out that way. Okay, so for all the problems for practice, what you should do is keep writing this every time. And that's how we work with a difference of cubes, which leads us to number 5. All right, so if we look at number 5 in the practice problems, we have x to the 6th minus 1. So x to the 6th minus 1 might lead us to think, well, that's not a difference of cubes at all. And I would actually beg to differ. If you remember from our previous lesson on factoring using substitution, what if we say a is x squared? Wouldn't then a to the 3rd power be x to the 6th, right? So that means then a to the 3rd power is x to the 6th. All right, so that's what that means. Okay, so yes, we are looking at a difference of cubes, because if we say x squared to the 3rd power is x to the 6th, then it's a difference of cubes. All right, so we're saying a is x squared, b, of course, is 1. So we are now set for our formula. Okay, we're set for the difference of cubes formula. Okay, so we have a cubed minus b cubed. And again, like I said, always rewrite the formula so it'll help you remember. So the first sign is the same. Then we have a squared opposite, and then always positive, SOAP. Same, opposite, always positive, SOAP. And so we have our signs. All we have to do now is switch back. So if we switch back, we substitute back in what we said originally, then we are good to go. If you remember, we said a was x squared, right? So we have x squared, and then b is 1. Hopefully you have an alarm bell ringing right now. If not, I'll talk about that in a second. But you should have an alarm bell ringing. Now we have a squared plus ab plus b squared. What did we say a was? A was x squared. So we're looking at x squared squared. And then we have our plus a times b, or plus x squared times 1. And then our plus b squared, our plus 1 squared. All right, so now we're just going to simplify what we have, and then we'll finish up in a second. All right, so we have x squared minus 1 as our first factor. Then this is going to be x squared squared, or x to the 4th, and then plus x squared, and then plus 1. And this cannot be factored, right? So this can't be factored. So that one's done. This one can't be factored. Remember I mentioned your alarm bells going off? Did you recognize that this can be factored? Ah, yes, can be factored. This is a special. So that first factor that we have, x squared minus 1, can be factored. It is a difference of squares, which, if you remember, factors into conjugates. And so we have x minus 1 times x plus 1. That's going to lead us to x squared minus 1. Remember, that's how that worked. So we had to always pay attention. And so always factor what we can. And now this is completely factored. So we have finished here. Okay, so always keep your eyes out for something that can still be factored. This is a fun problem. So I put a note on this one. I like that one. That's a good one. And now for the last one. Looks kind of complicated, and it is. So we're going to walk right through it and do a good job. So here is our last one. We have an interesting expression. So we have 3x to the 6th y squared minus 81 y squared. And so you're looking at it, you're like, well, that's not a difference of cubes. And I totally agree with you. This is not a difference of cubes. But what do we do first when factoring? Always look for a greatest common factor. Always look for a greatest common factor. Okay, so another winning problem right here. So we always look for a greatest common factor, and in these two terms, the greatest common factor is 3y squared. And when we factor out a 3y squared, we're going to be left with x to the 6th minus 27. And x to the 6th minus 27, no doubt, is a difference of cubes. All right, so this is, no doubt, a difference of cubes. If we let a be x squared, and we let b be 3. All right, so if a is x squared and b is 3, we can recognize a difference of cubes. This is totally challenging. I love this one. And so now if we're looking at that, then we can see that we have a cubed minus b cubed, which leads us into our difference of cubes form, same, opposite, and then always positive, SOAP for the signs. Okay, so we now have that, and then we can switch back. When we switch back, we have x cubed, or excuse me, x squared, that should be an x squared, minus b was 3, and then we have a squared, or x squared squared, or x to the 4th, plus ab, right, plus 3x squared, and then plus b squared, plus 9. Right? So we have factored out that difference of cubes. And this can no longer be factored. This is not a difference of squares, so that's factored. That's done. So notice the difference between the previous problem and that one. This one's actually done. But we're not finished because we don't forget that first factor that we had factored out, 3y squared, and then we have x squared minus 3, and then we have x to the 4th plus 3x squared plus 9. Hooray for factoring. And that, my friends, is a difference of cubes. And this whole unit, or this whole lesson, was on the sum and difference of cubes. So hopefully you had a little bit of fun. This is challenging, I'm not going to lie. You're going to need practice. The only way to learn math is do math. So make sure you're practicing, do those textbook assignments, and I'll see you after you're successful. Take care.